Hello, hello, hello. Can you guys see me? Hello. Yeah, I think we are live. Hi. Yeah, we are there. So, what are we doing today? Let me see. Yeah, okay. What are we doing today? So, I came up with some idea. I'll just show you guys. Let me first create a project. I'll just name it. Let me name it Open Animal. So I'll tell you what it is. Oh, hi. Hi, Smith. What's up? Kai re, big man here. So, by the way, is the voice good, Smith bhai? काय रे भीक मांग्या काहीतरी चांगलं कर जीवनात. दीपक कलाल सुप्रीमसी. कॉपीराइट स्ट्राइक आने दो क्या? दीपक won't send me.
क्या रे भिक मंगिया क्या दिख रहा है? हाँ हलवाई क्या?
हलवाई क्या?
दिहाड़ी लगा था.
जोड़ी.
क्या रे भिक मंगिया क्या दिख रहा है? हाँ हलवाई क्या?
रुक रुक. मेरी जान लगे मेरी जान.
अरे काहीतरी चांगलं कर जीवनात. नाही जनाची तर मनाची तर ठेव. अरे बडव्या कशाला हे सगळं करतोस? चांगलं जीवन जग की. अरे राजासारखं जीवन जग माझ्यासारखं.
माझ्यासारखं.
पण सोड साल्या तुला काय सांगायचं.
तू हृदयासारखंच जगणार.
निघ इथून.
वेले पार्क.
अरे काहीतरी चांगलं कर जीवनात.
Anyways, so okay, let's get back. So, yeah. सातचं बुकिंग आहे स्मिथ. Okay, so let me see. So this project, right? What I thought of is yeah. So let me create a file. Thoughts.md. अरे कर ना बुक माय आयटी ब्रो. ते नाही जाऊ दे मी करतो नंतर. बॅडमिंटन. सो द आयडिया इज that the model, whatever it is speaking, is the is the internal thought along with the actions itself. So current LLMs in their RLVR they don't have access to the environment directly. The reward which they get is basically at the end of the trajectory. If you guys, so I'll explain this, right? So how I'll just show you what I'm saying. So currently, if I, one sec. So if you check the DeepSeek paper, right? This paper, right? Let me open notes. One note in this thing. So this paper, right? What this introduced to us the GRPO, right? So I'll just create a new notebook. GRPO Manimol. So let me create a new notebook. Yeah, so draw. So what GRPO did was basically you have a LLM, right? And LLM is for a question, right? For a prompt, you put that prompt here. And normal LLM, what it does is it gives out a token, right? And normally what happens is this token is trained based on some kind of a data set. The probability of this so basically probability of the token is increased based on the true token, right? So this is normal training, and what happens in GRPO is what they do is they create a trajectory, right? So they use this LLM to create a set of tokens, right? So this is a trajectory basically. And then there is a conclusion. Okay. Now, if this conclusion is right, or for example, this set of tokens or a trajectory is right, you give a reward to it, right? So if I write it down, reward you get for either having the right format or set of tokens in some kind of reward environment, or the right action. So when the system like Owen or let's say any modern LLM, it thinks and gets to a action, right? That action specifically is either that conclusion or what it needs to do next. But the main reward it gets is either it's basically for this conclusion, right? So this conclusion can be one token or it can be another trajectory, right? Another trajectory. But the main reinforcement has to be done to this main trajectory, which is basically its reasoning, internal reasoning, right? So what I am thinking of, so for this, basically you can check out this DeepSeek R1 paper, right? And for the algorithm, yeah, so here is the GRPO. So where is the prompt? Let me check the prompt. Yeah, so if you see, this is the question, right? Response mein there is a think token attached, right? Now this think token, whatever is happening inside it is what the model is thinking about, right? And what you get, right, at the end. So this is, look, think has stopped here, and then whatever is the next is basically the conclusion part, right? Now what you can do is you can have like a mechanism which will check this basically out, this conclusion. And what you do is you do a SFT, which is supervised fine tuning on what kind of structure you want for the conclusion and the reasoning trace. And then what you do in GRPO is basically this set of tokens or trajectory is sampled. So what happens is this LLM samples like 5 responses, A, B, C, D, E, right? C, D, E. These are a set of trajectories, right? Not single tokens. And what you do is you find out an advantage, right? Based on like internal ranking. So you don't have to reward it based on some kind of previous data set. What you do is you take this first trajectory, which could be, let's say, either like this trajectory or some trajectory, right? And what you do is the formula for GRPO, right? I'll show you. So GRPO formula. Yeah, so this is the advantage, right? So this is group relative advantage. So what you do is you get a mean of the reward you got. You take the standard deviation of the reward you got, and you subtract it from the this thing, the critic, right? Yeah, from the reward of that specific trajectory, and that is your advantage for that trajectory. So what you do is, let's say for a trajectory, right, the trajectory didn't work out at all, but let's say B, C, D, and E did work out on an average level. So you got some average reward out of it based on, let's say you're doing a coding thing. So that code got the steps right, the syntax was right, and the conclusion was a little bit problematic. So you get some reward for B, C, D, E, right? But if you take the average out of it, and what you do is you subtract the mean and divide it by standard deviation, you get the advantage for A, which will be negative. So all the tokens in the trajectory trace, right? All the tokens, so here all tokens for a small or negative reward compared to the other 4. This A will would have a negative advantage, and hence the probabilities will be taken down, brought down. So this is basically how GRPO works. Now what I'm thinking of is this conclusion part, right? What if somehow we are able to So currently what is happening is this set of tokens in the trajectory of the thought are only reinforced based on the conclusion and how that conclusion works. But what if we let the model do experiments inside its brain, and we just give basically either let's say a model based environment which would also be trained, but for now like a proper environment which is giving it reward, like how general GRPO works, but then also we are rewarding the conclusion of all those 5 traces. So it might not be making sense. Let me show you. So what I'm thinking of is, once you train using GRPO, it knows a path, right? So it's doing some reasoning. This is the LLM. This is the LLM. It's doing some reasoning here, right? Then it's doing a conclusion, right? Now, this entire thing, this is one action, right? Now what you're doing is you're doing this reasoning conclusion, then some, let's say, action, right? Reasoning, conclusion, action. Either this action is done on a real environment, or you're doing it on a model inside your brain, right? And what you do is you get some kind of output, right? So you get an output from this. Now this output you can train to get the reward, but what you can do is you can have a temperature parameter here itself, and this entire thing can be a reasoning trace. So after you get that output, you summarize, right? And what you do is the entire trajectory of your actions and rewards, action, reward, action, reward, you sample multiple trajectories out of it. Let's say 5 trajectories of this infinite loops. And then what you do is you give a bigger reward to all these trajectories. Basically, you give a reward, again with some kind of a GRPO. Now what the model will learn is what kind of experiments it has to run to get to a real good output, rather than just local reasoning, right? And so basically this works. And what you do is, I think, so let me first use an LLM. Let's get to coding part of it. Let me use Codex. Okay, so basically in GRPO we train a LLM to give a reasoning trace, which is basically reinforced based on the output of the output after the reasoning. Happens, and this is used to calculate the this is used to calculate the group advantage, right? So what our idea is basically, so for longer loops or long range tasks, what we would do, longer range tasks or loops, the environment only acts after the reasoning has been completed and the action has been sampled. For long range tasks or loops of such actions, the complete trajectory, right, of let's say a research agent would be trained using a reward given to the final model itself rather than individual environments. So, for example, we have a robotics ML task. The model would train a model, let's say ML task. The LLM train a model, get reward, train a model, have a conclusion which involves many set of reasoning and action pairs, and then we sample multiple trajectories of such action reasoning action reasoning attempts by the LLM to solve the task. For each, it getting a reward or some feedback from the environment, and then have a GRPO to improve the model even more to where we want it to be, right? So this is the main idea. Let's see if what corrects things out of it. So okay, so check thoughts.md and tell me what the idea is about. Let me use Medium. So this is the idea, guys. If you have any doubts or questions on what we're doing, do ask in the chat. I'll explain. So this is absolutely right. Yeah, so extending that to long horizon agent tasks where the model performs many cycles like reasoning action, observation, reasoning action. Exactly. Each unit of the environment gives feedback only after the overlap finishes. For example, a research or ML agent might try to train a model, experiment, inspect results, adjust code, and finally produce a conclusion. You will sample several complete attempts, score each final trajectory, compute group predictive advantages, and use exactly. So given I have a also one caveat, the reward or conclusion from the environment or output could either be a real output or a model inside the LLM, which is a prediction of the output, so that we can scale the training with GRQ even when the model is in the environment to train the task is not present. This will make the model learn the dynamics of the process. I think for starters, this could be just a output token, output tokens like the reason it has, and that could be so this is the idea. So what's it saying? Important second layer to the idea. Proposing that the environment feels like a trilateral level GPU does not always need to come from a real external environment. It could also come from a learned internal environment model inside of the element. So the training setup becomes something like LLM, reason action, predicted observation, reason action. The reward comes from either real environment output learned. The key idea is use model predicted environment feedback to scale GRP training even when the real environment was slow, expensive, or incomplete. This will push the LLM to learn not only better reasoning action policies but also to answer the task process. What usually happens after an action, what outcomes are likely, and what trajectory leads to success. A cleaned up version of the idea. But keep in mind, the main reward is the final accuracy of the trained model, so which would be used to calculate the advantage. central reward signal is still the final task outcome, especially the final outcome of the model trained by the agent. Right. So the predicted outcomes are auxiliary scaffolding that help the agent continue training or simulating to the cleaner version is. Will the agent's full track tree produce a better final model? No. So the question is, did the which of the 5 sample trajectories of a reasoning LM, which include action, observation from environment, reasoning, and again until the agent thinks it is there. Give the most reward, and GRPO is done on top of these trajectories. Yes, the core training question is, among the 5 sample full agent trajectory produce the highest final reward. Right. Then GRPO compares the final reward within the group if the rewards are exactly. Can you create a .md file with this idea and also a plan phase 1.md to implement this? I have a something which I want to use. Also, for the environment, would we need something like open? So could we use a open router, open code basically to do this? Yeah, so have you got this right plan? So let's see the plan. Put our trajectory GFF for the phase 1 system. Fall raising model, run our simulate actions and control our score each trajectory by final model accuracy. GRP, the final version, it should be a narrow experiment runner that proves training loop. Phase 1 avoid full fine tuning large models quantize and runs. 2.57b. No, but the so check your plan. The problem is that the LLM is not choosing to code or to act based on the feedback it received from the terminal. So it would require open code, in my opinion. emits reasoning, tool action intent, open code, edits files, run terminal commands, capture, exposes environment back, trajectory log, recorder, okay. Final runs, benchmark, evaluates script, returns final accuracy. Yeah, so open code is not just convenience here. It becomes an environment interface that lets the model condition or real feedback from the terminal and decide the next action. Control action environment, good for proving GRPO mechanics. Open code, needed for learning real iterative coding behavior. I would upgrade to make open code. Yes, change the plan. So that's the idea, guys. What do you think? What was the question? Is that Carla on the thumbnail? Yeah. Actually, I didn't change the. This is Carla. But we are building something different. I didn't change the. What do you say? I didn't change the thumbnail. We're building something different today. Do like the stream, guys. It's building the plan. Let's see. If you guys have any doubts, do ask. We will continue this after some time. I'll have lunch, maybe. But yeah, this I think is a quite nice an idea where the LLM has an internal understanding of what the output of that model will be, and that is explicitly written down as output along with the real output, and then that comparison is happening inside that LLM as we train the trajectories. And also, like this long range agentic tasks, right? We can actually train a very small LLM to get it working. For example, like Quen, what's the latest? Search for the latest coding LLM which are quite good. That would work in our project. So what's the idea? Okay, what's the plan? Open code runtime integration. So run one coding agent trajectory against an isolated copy of the task repo. What is it doing though? So level GRPO, okay. Should sample multiple complete coding agents trajectories from a simple learning model. Let the agent edit code and react to terminal feedback. Score each trajectory by final model accuracy and prepare the data set needed for GRPO. The final runtime, the most models learn when it respects files. It's using Quen 2.5. Let me search the Quen 2.5. when, let me check. So DeepSeek, when, how good is Gamma? So we have Quen 3. There's no Quen 3 coding model, huh? Quen 3.5. No Quen. So we have a 4B, right? We can also use Quen 3.5, right? So what? Okay guys, let me do a research on which LLM to pick up, and we will start first time training of this. I'm going to open source this project. I'll link the GitHub link in the basically in the chat or in the description of this video, and you can join in that repository and keep commenting on the video. I'd love to do that. And the second part will come soon. I'll go for lunch now. I will do the live stream again. And the basic idea is to create like a researcher. And on the very start of it, what we're going to do is we're going to train like a coding LLM to improve its coding based on the final model. For example, if you're training an ML model, what we want to do is we want to train that model, like use an environment like open code to train that model, and then again iterate, keep on iterating, and this entire trajectory until the model thinks that the final model accuracy is what it wants and is best, then it will stop. But then we will have more such trajectories, right? 4 or 5 trajectories, and the best accuracy or reward is what we want, and then we will train a GRP on it. So see you guys. Let's see how this project comes out to be. So do jump in whenever the next stream happens. I'm just checking if February Onslaught. Can you? Okay, we have this 20.5. We want 4B, 9B, right? And this one. So let me give the link to these models. 9B. And also the main. Let's see. Okay, guys, see you back. I'm stopping the stream now. Thank you for joining in. Do like the stream and hop in whenever we'll do this again. Thank you. Do subscribe.